Engineering teams are accelerating their output using AI coding assistants to generate software in seconds. But this speed creates a visibility gap. When an engineer interacts with a raw chat interface, the AI produces a result instantly, but the logic and reasoning used to get there remain hidden. This creates a dark box where you can't distinguish between a human's architectural intent and a machine's hallucination. Operating at this pace without a verifiable record is a significant business liability. It makes the development process impossible to audit. The breaking point happens when a client or a regulator asks for proof of how a specific AI-generated feature was reviewed before it reached production. Most teams rely on a combination of blind trust and scattered chat logs. They assume engineers followed the company's internal guidelines, but they have no way to prove it. This lack of evidence leads to compliance violations in large enterprises, quality failures in agencies, and structural chaos in growing startups. Internal policies are useless if an AI agent can bypass every required check without leaving a trace of why it did so. Organizations can no longer rely on the assumption that a developer checked the work. The system must force the AI to provide its own evidence. FRAIM is an orchestration layer that sits between the engineer and the AI. It manages the process of the work without ever reading the code itself. The source code stays on the local machine. FRAIM only captures the metadata of the session, the timestamps, the phases of the work, and the identities of the people involved. It replaces open-ended chat with structured jobs. A job is a purpose-built workflow designed for a specific business outcome. Every job contains a series of mandatory phases, repeatable skills, and always-on rules that define exactly how the AI is allowed to behave. An internal AI mentor enforces these gates. It prevents the agent from advancing until it produces verifiable evidence for every phase, from initial design to final validation. This structural oversight transforms a series of vague prompts into an inspectable log of every decision the AI made. This structure allows any organization to scale their AI usage without losing control over the quality. Enterprise teams use these jobs to turn manual security reviews into executable steps that generate SOC 2 compliance evidence automatically. Agencies use job structures to enforce identical quality gates across multiple client portfolios, ensuring that every deliverable meets the same standard regardless of which engineer is running the task. Because FRAIM manages the process of complex tasks, startup founders can use the same jobs to move from a raw problem statement to a customer discovery report, and finally to a validated investor pitch. FRAIM replaces the need for blind trust with a system that requires rigor and produces predictable results at every step. This structured metadata provides engineering leadership with a systemic view of the entire organization. By aggregating individual evidence trails, FRAIM identifies recurring mistake patterns, like a specific team frequently skipping UI checks, across hundreds of different jobs. Managers use these patterns to adjust the global rules, permanently fixing the workflow to prevent those errors from reaching production again. Identifying and resolving these systemic risks is more efficient than repeatedly correcting the same individual mistakes during manual code reviews. Standard operating procedures are now executable instructions. Governance is structurally encoded into the development cycle, allowing the system to enforce company standards automatically. To trust an AI assistant, you need a phase-by-phase evidence log that shows exactly what was generated, what was reviewed, and who approved it. FRAIM provides that exact record every single time. It finally makes AI-assisted engineering completely predictable, meticulously rigorous, and fully auditable across your entire enterprise.